We are going to start talking about exponential modeling today. So we're still sticking with exponents, but now we're going to look at sort of real life applications. And when we do this, we have basic equations that we use. The basic or general form of an exponential function is this form here. That means they're all going to take that general shape. The letters just may be interchanged with other values. We may have E's instead of B's. We're going to have a few changes, but that's the general form. So let's talk about what each represents. This Y value over here is always going to represent our ending value, our end value, our end amount. Okay. If we put money into an account, it's what I end up with after I gain some interest. A represents the initial amount, how much you start with. Okay. B is our growth or decay factor. Okay, it tells me how much it's either growing or decaying. By decay, I mean going down in value. X, it's going to be representing time. So this is the unit where we start using our Inspire. You are going to need your Inspire to be able to find the answers to these. So if you don't have your Inspire, you need to do that first and foremost, because in this video, I'm going to show you how to use your Inspire to get your answers to these problems. So the first problem they give me is f of x equals 500e to the power of 0.1 times x. Now, e is not just any variable. I've put a clip here, or I'm sorry, a link to a video that talks about e. E is an irrational number, and it's kind of like pi in that we use pi so often that we came up with a symbol for it. E is a little bit like there. There's a whole history for it. I'll go over that with you in class. You can also click this link. But it represents an actual number that we use. So if I have this equation, we're going to be solving for f of x and we're going to be solving for x. We're going to use our calculator, the graphing part, to solve for the actual x. So that's what I'm going to go through in this video. But let's start with if all I'm solving for is the f of x or the y. Then I'm going to substitute what they do give me into my equation. And they told me x was 0.52. So I'm going to go over to my calculator, and I'm going to input my information here. So if you pull up your calculator, you want to, if you're on the home screen, we're going to go to a calculator page. And I'm just going to type in my information. So I've got 500. Now your E button is down here. It's E to the X. I'm going to click that, and then I put in my information. So it was 0.1 times x was 0.052, and I click enter. And I get 502.607. So that means when x is 0.052, my answer is going to be 502.61. I just rounded to the nearest hundredth. Now, those are the basic steps. If all I'm doing is solving for f of x, that's the easiest part. All I do is put in the calculator, and it's going to give me my information. On the next part, this time, I'm trying to solve for x. Well, if you notice, x is in the exponent. So it's not going to be so easy to solve. And the way I'm going to do this is I'm going to use my graphing calculator. And I'm going to have my graphing calculator help me get the information. Now on the next page of notes, you'll notice I have the steps. But I'm also going to walk through those steps with you. But you can come back here and read as well, or you can just listen to it again. So what I'm going to need to do is go to my graphing calculator and graph each of these functions. Because if I substitute in, I'm trying to find out when f of x is 400,000, what is x. And the way I do that is I graph, this is one function, which is going to be a horizontal line. And this is another function, which is going to be some sort of exponential curve. And I'm going to find the intersection of those two pieces. So that's two functions that I have to graph on my graphing calculator. So on your graphing calculator, if you're on the home screen, you want to open up a new graph. And it should automatically start you at your function. So the first thing I'm going to enter is my equation that was at the beginning, 500 e to the 0.1, and I'm actually going to put x in there, the variable, and click enter. Okay, I'm not going to be able to see anything because I've got to adjust my screen to be able to see this. But before I do that, I'm going to graph my other function. So if you hit tab, it's going to take you to a second place for a second equation. And all I'm graphing is f of x equals 400,000. Make sure you don't put any commas because it doesn't read commas. So I'm just putting 400,000 and click enter. Now, I still can't see anything, so I'm going to have to adjust my window screen. And there are easier ways to get to where we want to be. So the first thing I'm going to do is go to Menu, Window. Now, window settings is an option I'm going to use, but first I'm going to go to just Zoom Fits. What that does is helps me at least see some of my graph. But here, all I can see is my exponential curve. I need to see that horizontal line as well. So I'm going to have to adjust my window settings. Okay, my x's right now are at -10 to 10. Well, I want my x value to be bigger than that, so I'm going to make it 50. And down here, I know my horizontal line is at 400,000, so I need it to be a little bit bigger than that. So I'm going to make it 450,000. Let's see what that does. So I can see my red line, and I see my blue curve, but I still can't see where these two intersect. And they're going to intersect over here, you can tell, because it's starting to curve up. So I'm going to make my x's a little bigger again. So I'm going to go here, and I'm going to make it 100. And say OK. So now I can see where these intersect. But I don't want to guess that. The calculator will actually find that intersection point for me. If I go to Menu, Analyze Graph, Intersection, now it's got this dashed line moving. It wants me to shade over where I'm looking for the intersection point. So I'm going to click on the left side, and then I move it until the intersection shows up, and click again. This is my intersection point, and what I'm looking for is that actual x value. That's what I'm trying to solve for. So my x value is 66.8, which is the answer to the next problem. Simple as that. We are going to do some more practice on this. So why don't you see if you can figure out the next one, and then I'll jump to it with you. Okay, so I've substituted all my values in. M is 2500 and X is 2. I'm going to go to my calculator. I'm going to hit the home screen again. And I'm going to go back to a calculate page. And I'm going to enter my information just like I substituted in. So I got 2500 times 1 minus E. And then I have a negative 0.5 times 2, and I click enter. Gives me 1580. So the answer to that part is just 1580.3. That found the answer to that. This part I'm going to have to graph. So I'll do that part next. You try to do it, and then I'll guide you through it. All right, so on the next part, in 3B, remember, this is where we're going to use our graphing. So h of x equals 32. So I'm going to go ahead and substitute everything in. M is 300. I write everything else out. Remember, I'm going to graph this as one function, and this is another function, and find the intersection. So I go back to my graphing calculator. I go back to my home screen. I'm going to click graph, and I'm actually, one thing you can do to start over each time, which you may want to do, is if you click dock and go all the way down to number 9, no, all the way. I think if you do dock B, I believe, maybe I'm wrong. Oh yeah, there it is. It will clear your scratch pad and you can start over. So I'm going to go to my graphing screen and I'm going to graph the very first function, which is 300 times, and I use my parentheses,